Day training. It's brought to you today by Loy Instrument, and I'll be your trainer today. My name is Jeff Berger. I've met most of you on this line, but some of you I haven't. So looking forward to going through this training today. Each of the Tech Tuesdays that we do for the training, we're going to keep to about a 30-minute time frame. We can have questions towards the end of the training. But in order to make best of use of everybody's time, we wanted to keep it short but sweet. We do have a full training class that we offer usually before winter, early fall, and that is a complete combustion training class that lasts for a day. So for more information on that, we can send that out to you or contact Roger Stevens for additional details on dates and times. So with that, I'm going to go ahead and share a brief presentation with you, and we will go through the training here. So once again, my name is Jeff Berger. It's Tech Tuesday. Go ahead and pour yourself a warm cup of coffee or tea, and let's get started. Flame rectification basics. Flame rectification in combustion systems is probably one of the most basic ways of sensing a flame, but it's probably one of the things that's the most misinterpreted ways of monitoring a flame. So what we're going to do is we're going to go through some of the basics on flame rectification using flame rod and talk through some troubleshooting and how does a flame rod work. So we know that in a flame, there's definitely some characteristics that a flame produces, which we can monitor for combustion systems. The first one is production of heat, which is usually used with a bimetal or a thermocouple. These are typically pretty small systems like a water heater or maybe your home furnace. The next is expansion of gases. So we know that in a flame, you can have a lot of different, like CO, O2, CO2. So there's a lot of different things going on in a flame that can have presence of gases. The production of byproducts is another one that is not used real widely within the industry. Most of these are usually pretty expensive systems. So in most applications where you're monitoring a flame, they're usually not used. Emissions of light, so infrared, ultraviolet, optical detectors. This is one area we're going to cover in our next Tech Tuesday topic, and we're going to go into a little bit more detail into that next Tuesday. The last but not least is ionization of the atmosphere in and around the flame. So this is known as flame rod or flame rectification. It's pretty widely used out there in the industry. A lot of different applications for this. It's a pretty foolproof method of measuring the flame as long as you have the correct things in place in order to make that happen in the correct manner. What we found out, or I guess Honeywell found out back in the 1930s, is that the flame can actually conduct electricity. And the way that does that is by the ionization that takes place around the outside of the flame envelope. It's a pretty neat thing when you think about it. And the fact that back in the 1930s is when they were finding all this out is pretty remarkable. So Honeywell was the first one that came up with this form of flame rectification. And let's go a little bit more into the flame rod application and talk about that. First of all, the flame rod itself. Let's talk about some of the components that make up a flame rod. First of all, you have the rod itself. The rod itself can withstand temperatures of excess of 2,000 degrees, 2,200 degrees. So it's pretty robust, and it's just a solid rod. So a lot of times, customers or people that are actually applying this flame rod, they think it's actually a conductor of heat, and it's not. It is actually just a solid rod that connects up to the flame circuit and provides that conductivity into the flame. We're going to talk a little bit more about how the flame rod actually does the rectification and conductivity. But for right now, we'll keep it simple. The flame rod is supposed to have the shortest length possible, but still enough flame rod length in order to intersect both pilot and main flame. If you don't have pilot, then obviously just intersecting the main flame. You can actually cut these to length. So, for example, in your truck or in the crib, if you have a 12-inch or 20-inch long flame rod, you can actually cut that to length if it's too long for your application. The next is the connection there that you see. This is an NPT fitting that actually fits into usually the casing of the burner that you're using. You can screw that into the top of the burner. In most cases, the burner manufacturer already has the ideal setting or the ideal placement of where that flame rod is supposed to put into the burner system. So that is your connection into the burner. Last but not least is the ceramic insulator. The ceramic insulator can withstand temperatures of about 500 degrees. So make sure that on the outside of the burner that it does not get above that, because if it does, you can have some issues there with leaking current to ground, and that's not a good issue. It's not a good situation there. Right at the end is where your wire connects, usually like a Raja connection, but it's a single wire that goes back to your flame relay base, your wiring base. Typically that wire there is number 14 wire. We like to keep the length less than 150 foot long. If you do get longer than 150 foot on your wire lead, you can run into some impedance on the increased resistance on the lead wire length, which would decrease the signal of your flame signal going back to the flame relay. So try to keep those distances as short as possible as well. Honeywell does have an amplifier, a booster amplifier, that if you do go more than 150 foot, you can boost the signal and try to get that voltage up going back to the flame relay. So let's move into talking a little bit about how the rectification process happens through the flame. You can almost think of a flame rod circuit as a light switch. If you're properly putting the flame rod into the flame and you have a good earth ground, the AC signal is actually imposed on this F lead coming out of the flame relay wiring base into the flame rod. And that AC signal is about 220 volts. So even though it has very low current, it won't really so much hurt your hand when you touch it with your hand or your screwdriver. It's going to probably hurt more your elbow because you're going to pull away from it really quick and hit your elbow on something. So just be cognizant that when you do have this flame circuit powered up, that there is a high voltage that's coming out on this F lead through the flame rod into the flame envelope. So the AC signal is applied. It makes contact with the ionization that's happening around this flame, and then continues down through the actual burner assembly down into the ground. When the AC signal is in the positive, you're actually sensing the flame. This signal from midline to the top of that AC signal is about 5 microamps. So if you put a microamp DC meter in series with this F lead, for a really good signal, you should be reading about 5 microamps. The threshold on that is right around 2 microamps. So you have to be 2 microamps or more in order for there to be a good flame signal going back to the flame relay. If you have a Honeywell flame relay, like an RM7800 series, that signal is actually amplified and shows up as a voltage in the display of the RM7800 series. That display shows a 0 to 5 volts and the bottom threshold being 1.25 volts. On the bottom side of this curve here, we have about 1 microamp. The reason why that shows the AC signal in this format is because of this earth ground. This earth ground needs to have a ratio of about 4 to 1. So the ground needs to be about 4 times larger than the area that you're sensing inside of this flame envelope. That's how we get the bottom end here looking like, it almost looks like a DC pulsating signal. And we do this by the rectification circuit and this ground here that's attached to the burner assembly. The things that's required for a good stable flame or a good flame rod application is you have to have stable flame, so you have to make sure that you don't have like a candle effect or any type of flame flicker that would actually cause the flame to move outside of where the flame rod is being positioned inside of that flame. The other thing that you need to make sure of is that the first thing that we always hear from customers is that when they find out that the flame rod is not giving them a good signal back to their flame relay, what's the first thing that they do? They usually turn up either the pilot gas or they turn up the main gas using the regulator. What that does, it actually, if you increase the pressure, most times will lift this bottom end of the flame off of the burner nozzle. And what happens when you do that? Well, the first thing that does is it breaks the circuit. Because when we were talking earlier about the flame rod looking like basically a light switch, that right there is opening the light switch or turning off the light switch and breaking the current that's flowing through the flame down through the burner nozzle down to ground. So the one thing that you might want to consider if you're not getting a good flame strength, either using or measuring by your either DC microamp meter or your flame relay display, would be turning back the pressure on your pilot or the main gas in order to let that flame actually sit back inside of that nozzle, making a really good earth ground connection. I would say probably one of the most important things for a flame rod to really be conducting and giving you a good flame signal is the grounding. That is one of the biggest things that will deter or deteriorate the flame signal back to the flame circuit. The other thing that will also add some complexity to getting this flame signal at a good solid reading would be if you get soot, or if you have any moisture or any type of buildup on the flame rod itself. What this does is when you get soot built up on the flame rod, it actually starts adding insulation and starts to change that 4 to 1 ground ratio. So what it's actually doing is adding grounding surface to the flame rod itself, and it changes that 4 to 1 pretty dramatically. And when it does that, it actually starts dropping that voltage signal back to your flame relay to hold in for that flame circuit. So what you typically want to do on a regular basis, you want to take like a fine grit sandpaper or like emery cloth or something like that, and you know, at a scheduled interval, depending on how good your burner's working and how much soot it's actually placing on that flame rod, you want to go in there and remove the flame rod and clean it and put it back into operation. So that's one of the key things there, and some preventive maintenance for that. As we talked about, adequate ground. You're going to hear me say this over and over again. Grounding is the biggest thing that you need to be looking out for when you're trying to get that flame signal to a steady state and make it a good flame signal going back to your flame relay. A couple different ways that you can actually add grounding surface to either a pilot or main. You can add grounding surface by taking two flat plates and putting it on top of the burner nozzle, where the actual flame would be coming out over the edges of these plates here, making an additional grounding area. The other thing that I've seen work really well is placing the pins around the burner nozzle and having each one of these pins touch the flame envelope, which actually adds the grounding surface as well. I've been on applications where, we've had a pretty poor flame strength, and one of our service people that we were working with had some welding rods that he went out into his truck, brought in and bent them up and put them inside of that nozzle. And each time he added one of those rods into the nozzle, you could really see the increase in flame strength going back to the flame relay. So it does work. I've seen it firsthand. Usually adding the rods is a better method for adding grounding surface versus these plates. Because even though you would think that there's more grounding surface here with these long plates in the middle, really the only thing that's touching the ionization around the flame envelope is these corners here. So even though it's adding more grounding surface, you have virtually probably 4 pins here versus 8 pins or 6 pins on this one on the right hand side. So that's a good way to add grounding surface and to help get your flame signal up. The other thing is proper flame rod location. So typically you're going to want the flame rod intersecting at the bottom of the flame, coming up through the pilot and the main flame, or coming into the side of the flame. You typically do not want to place the flame rod right above the flame, because what will happen in those situations, if you have inadequate pressure going to that pilot or main, and you have something that's called a candle effect, where it's a lazy flame that maybe at low fire is adequately surrounding the flame rod. When you go to high fire, or when you change the regulator pressure, it's going to straighten out that flame, and now your flame rod is not going to be positioned in a proper location into that flame. So you always want to be either on the side or coming up through the bottom of the flame envelope, and that should provide you a really good connection into your flame circuit. The number 4 here is the proper flame circuit. So the proper flame circuit is all the components that will help carry that signal back to the flame relay to pull in the relay in order to make sure that your flame circuit is operating properly. One of the big things that we see out there in the industry is improper flame amplifiers for the application. So in the Honeywell world, in the 7800 series flame relays, there is a rectification amplifier, and that amplifier is denoted by a green label that's on the front of the amplifier, and it should say flame rectification on it. There is 2 different amplifiers that's offered throughout Honeywell. One of them has a 3-second flame failure response, and the other one has a 0.8-second flame failure response. You have to make sure that you have the correct amplifier for not only the detection that you're using, but also if your flame relay is set up for recycle on flame failure or lockout on flame failure. We will get into those details on a later Tech Tuesday topic that we'll discuss. But for right now, let's just focus on having the correct amplifier to amplify that rectified signal going back into the flame relay. So number 1, stable flame. 2, adequate ground. 3, proper flame rod location. And 4, proper flame circuit. As I stated before, a great flame signal is 5 microamps or 5 volts DC. The lower threshold is 2 microamps or 1.25 volts DC. So let's see here. All right. What I'm going to do is let's just go over a real quick checklist again. Make sure that we covered everything from a flame rod application standpoint. First of all, a flame rod is not sensing the heat of the flame. It's actually providing a circuit for the flame or for the current to flow through the flame rod, through the flame, down through ground. So an adequate ground is required, 4-to-1 ratio. Keep the flame rod as short as possible. This will help in proving a good flame and applying the flame rod in the correct manner. Having the flame rod leads be number 14 wire, and try to keep it 150 feet or less. That would be ideal. Temperature at the flame rod insulator needs to be 500 degrees or less. Otherwise, you're going to have some issues with that ceramic insulator being a conductor for you. And the other one I didn't really talk much about, but is applying protection against ignition interference. So if you have a flame rod that's close to your igniter and you see that spark jumping over to the flame rod, it's probably not going to be long before you'll probably be calling us or somebody else to have that amplifier or flame relay replaced, because you're inducing a AC voltage, a pretty high AC voltage, back into the flame circuit, which is never a good thing. So make sure that that you keep the flame rod distance away from the ignition as good as you can, or protect it as well as you can, and that'll help save the life of your flame circuit and flame relay. The other thing is, last but not least, and I'll say it again, is good grounding. You just need to make sure that you have an adequate ground to provide a good current signal or current through the flame down through ground. With that being said, that kind of wraps up our morning session, Tech Tuesday. I appreciate everybody's time. At this time, we can open it up for questions. If you want to type in your question, we'll see it pop up on the screen here. And if there is no questions, then we'll go ahead and adjourn. Yeah, looks like we might have some people muted here.
Can you hear me, Jeff?
Yes, I can.
All right. Kurt's wanting to know, he says that he wasn't always thought that you're not supposed to use sandpaper on a flame rod.
You're yeah, you use like an emery cloth or something like that to clean it is probably better. You know, although you're not gonna damage it too much by using like sandpaper if you needed to. I mean, if you have a lot of soot built up on there, that you know, you're gonna have to use something pretty aggressive. But again, it's just a solid rod. So unless you're taking like a sanding wheel or something like that to it, where you're really decreasing the diameter of that flame rod, which again is going to change your grounding ratio, you should be okay.
Okay, so if you use like a sandpaper, then go back with an emery cloth to make it more,
Yeah.
There's no grooves or anything, and you're not changing the surface area that much, correct?
Yep. Yep.
Okay, that's what he needed. Thank you.
No problem.
All right. I have a question. Is there a minimum length? I mean, as long as it's in the flame, I was always, you know, there's no real minimum or maximum length, because since it's just a solid rod.
Yeah, there's no minimum or maximum, as long as you have you want it to probably extend, maybe an inch or so beyond the flame envelope.
Okay.
That would probably be a good application for that. You want to make sure that it extends both through the pilot and the main flame envelope. That's really just the largest requirement there.
All right. Thank you.
No problem.
Jeff, can you hear me?
Yes, I sure can.
Okay. My question is, you said in terms of flame signal on the high side, you like to see 5 volts DC, 5 microamps. On the low side, 1.25 volts DC. And how many microamps on the low side is acceptable?
About 1 microamp.
1 microamp.
1 to 2.
Okay.
2 microamps would be solid. Once you start bouncing below that, it gets kind of sketchy, especially, if you have a 3-second amplifier, which most cases you probably do. You're probably going to be intermittently locking out every once in a while. So if you had 2 microamps, that would probably be best, and then anywhere between 2 to 5 would be ideal.
Yeah. Okay, thanks.
No problem. Yeah, and with the RM1700 series flame relays, you have a couple options to measure the voltage. If you don't have a display on the RM1700 series, on the front of the amplifier, there's a plus and negative. You can actually just use your voltmeter leads and plug them into the front of the amplifier, and you'll read out the 0 to 5 volts. And then with the Honeywell display, you get the voltage readout right on the top of the display. Any other questions?
Jeff,
Yes.
on the earth ground, that's the first I've heard of 4 to 1, and that's great that you've shared that, because now I know the material. Is there like a kit that they sell for that, or what type of material would you, and it looks like you on the picture that was welded to it. Is that the idea, to create more like the rods?
Yes. So you're typically earth ground, you'll probably have a rod, or a lot of times that ground that's on the flame relay itself, that's the same shared ground that you'll have on the control panel, the burner, the outside shell of the furnace, or whatever piece of equipment you're working on. So it's all the same ground. It's all a shared ground. It's not like you said, it's not like a kit that you buy to, weld something to the side of a, burner nozzle or something like that. It should be the same ground that's in the control cabinet where your flame relay is actually mounted.
Okay. Thanks.
But how do you add? I guess my question, now that he's brought that up too, is adding the rods you were talking about. How is that done correctly? Is what my question is now.
Right. So typically you're going to want a ground. In most applications, it's a ground rod that is actually fixed into the into the concrete or something like that, onto the side of the panel, or it's the ground that's attached to the panel. As far as like good earth ground from a electrical standpoint, you guys would probably have to refer back to the the standards for for wiring and stuff like that for the control panels. Typically we're just making sure that that ground area is usually shared with a larger scale ground. So it's going to be attached to the control cabinet itself, or it's going to be attached to the burner nozzle, or whatever is part of that system making up the ground. But for proper grounding techniques, you guys would probably want to refer back to some electrical standards or something like that.
Have you ever been in a situation where you've seen where they've been an electrical cabinet and actually had to add a ground to get the grounding that they needed for the flame rod to work
Yeah.
correctly? Have you seen that?
Yeah, yeah, I've
Okay.
actually seen where they've actually had to add add a rod into the ground in order to get a better grounding. Sometimes with those old panels, you guys have probably been into applications where you get into some pretty old panels, probably even dating back to the 1930s when flame rods first came out. Some of those applications, whether somebody's been in the panel or moved the panel, there's been situations where there just hasn't been a good ground on the panel itself, and as a result, you're not getting good connection back to the flame relay circuit that's sharing the same ground, and that's causing issues with the flame rod.
All right. That's the first I've heard, like Eric said. That's good. Thank you.
Yep.
Hey, Jeff, just
Yeah.
a quick adder to what those guys were just asking about. There are occasions when you may have, let's say it's a refractory block, and there's not enough ground surface where you can't get a 4-to-1 ground surface where you've got a good metal, solid earth ground back to the burner. If you're using refractory, that's not an uncommon problem. And to answer your question, I think that was Derek that was asking, you may need to take rods and actually tack them onto the end of the nozzle to extend out to get some metal, some actual metal from that cast burner head, the nozzle, out beyond the refractory to make contact with the ionization envelope in the flame.
Okay.
Yeah, that's a good point, Ken, because the other part of refractory is that when refractory gets above a certain temperature, it actually acts as a conductor, and will be bad for that flame circuit as well. You'll actually see the voltage dropping. So yeah, you want to make sure the pictures that I had earlier where we had the rods on the end of the nozzle, that's what Ken's referring to there. If you add some of those rods or actually weld or tack weld some of those rods onto the end of the nozzle and extend that surface area out through the flame envelope, that will greatly increase the amount of grounding ratio that you have, because that rod is attached to the burner nozzle, and then the burner's nozzle is also attached to a good earth ground somewhere.
Jeff?
Yes.
Yeah. In terms of the rectification amplifiers, you said there's the 3-second amp, and what was the other?
0.8 second.
Okay, so the 3-second amp is the pretty much the typical one that we use, right? The green one.
Correct.
Okay, what applications would require the 0.5? You said
0.8 second.
0.8. Yeah, what application?
Yeah, so in applications where the standards allow for the burner to be relit once the flame is lost, a 0.8 second flame amplifier will allow you to relight once the flame is lost. There's also in a combination with a jumper selection, resistor selection on the front of the amplifier, or on the front of the flame relay itself, that you have to make sure that you have those either clipped or intact based on how you want that flame relay to respond. So yeah, 0.8 seconds would be for recycle on flame loss. The 3-second will be for applications where you want it to fault out and lock out, where you have to actually press the reset button on the front of the flame relay.
You still see on those 3-second amps, you can still clip the jumper and have it not lock out on flame failure, right?
Let's see here. You
Yeah, because
can.
I've done it. Yeah.
Yeah, you can, but you actually have to change the amplifier as well.
Oh, okay. It's good to know.
In most applications, like FM, NFPA, IRI, depending on the burner size, they might not allow you to recycle on flame loss.
Right. There's not
So
many out there that we do that.
Yeah, you're probably going to want to check that as well.
Okay.
Yeah, so it's important there to choose the right. The in most jurisdictions, you know, with the NFPA and FM, they actually allow up to 4 seconds on flame failure response, but you know, Honeywell's taken it a step further and only offers a 3-second. So once the flame signal is lost, 1001, 1002, 1003, and then the flame relay will lock out and cause a reset.
Okay. Got it. Thanks.
Yep. Those are some good questions. Any other questions? So if you're like me, you probably need a reheat on the coffee or tea. So we really appreciate everybody's time. This is our first Tech Tuesday, what we were kicking off with everybody. As we move forward, there will be other topics that we add to the Tech Tuesdays. Please feel free to offer suggestions to Roger, and he will compile those, and we'll add more classes moving forward. Hope it was worth your time this morning. Appreciate that. And I know everybody's schedules are crazy these days. Please be safe out there, and hopefully we'll see you soon or hear from you soon in the next Tech Tuesday discussion. And with that, we'll go ahead and conclude. From our home to your business, appreciate your time this morning.